Hello everyone, this is Ankit Jain. I welcome you all to my channel Take Journey with Ankit. Today is day 23 of our LWC Bootcamp. In today's session, we will be discussing about the different lifecycle hooks available on the Lightning Web Component. Most of the lifecycle hooks are available in all the modern JavaScript programming languages, but here we will be deep diving specifically about the Lightning Web Components. So, before we get started, a quick intro about me. My name is Ankit Jain. I do have more than 10 years of experience in the Salesforce ecosystem, where I do got an opportunity to work on the different clouds, including the sales, service, CPQ, billing, as well as on the financial service cloud. And I do have my expertise on the Lightning Web Component as well as on the integration too. In case you folks likes to connect with me, these are the different channels are available. You can connect with me on YouTube, LinkedIn, as well as on the Telegram. You will get the links of all these different channels in the video description. So let's get started with the discussion. What is lifecycle hook? So in LWC, lifecycle hooks are nothing but a callback method. This is very important to understand. Lifecycle hooks are nothing but a callback method which will trigger at the specific phase of the component instance lifecycle. These methods will be triggered automatically. Manually, we don't have to trigger this method. Framework will automatically trigger this method on a specific phase of a component lifecycle. There are few methods which will be automatically invoked when the component is created. There are few methods which will be invoked whenever which will be invoked when the component is instantiated. There are few methods which will be invoked whenever we do have the any change in the property. Okay, so let's try to understand the importance of each and every method. So let's try to understand with this diagram. I try to make it more simplified from the standard diagram that Salesforce is provided so that it will be quite easy for you to understand. So let's assume that we do have the two different component. One is the parent component and another is the child component. Your life cycle will begin as soon as your DOM is initialized. That means your component is created inside the DOM. Again, DOM stands for document object model. As soon as your DOM has been initialized, this lifecycle hooks will invoked. So let's say you do have one component where we do have one component is the parent component, and inside the parent component we do have the child component. We are taking this kind of a scenario. So how the lifecycle hook will run? So the first thing what will happen here is the constructor on the parent component will run. Again, these are the different lifecycle methods that we will discuss down the line in detail. But from this, I want you to just understand the high level flow. So the first, the constructor will be invoked. After that, the next one, connected callback will be invoked. After that, in case your component have any render method, then that render method will be invoked. After invoking the render method, the control will immediately transfer to the child component. One key thing to note here is here we are not invoking the rendered callback method. As soon as the rendered method is invoked, the component is automatically transferred to the child component here. And after that, the child constructor will be invoked, followed by the child connected callback will be invoked, and followed by the rendered callback on the child will invoke. But key thing to note here is now on the child component, first rendered callback will be invoked, and after that the control is getting transferred to the parent component, and on the parent component rendered callback will be invoked. Again, I'm repeating the flow. It is very important to understand because when we start dealing with the complex component, most of the times we do get confused why the logic written in the rendered callback is not getting called. So always understand first the constructor connected callback and the render on the parent will execute. After that, the control will transfer immediately to the child component. Constructor connected callback and the render on child will execute. After that, the rendered callback on the child will execute, and after that the rendered callback on the parent will execute. This is how the life cycle of the flow will work whenever you are inserting the component inside the DOM. I am pressing here on one more word, that is inserting. This flow is specifically one. We are inserting the component inside the DOM. As I said, most of the lifecycle hooks method are built on the custom element specification. Custom element specification means the specification provided by the W3 web. Accordingly, these lifecycle methods will work. If you go to the Angular JS or if you go to the Node.js programming as well, in all those other programming languages, you will find the similar lifecycle methods like the constructor, connected callback, and the render. But there are two methods which are specific only to the Lightning Web Component, which is not available in other programming languages. That is the rendered callback method and the error callback method. These methods are only available specific to the Lightning Web Components. Now let's try to understand more about the first method, that is the constructor method. Here I tried to put as much detail as I can on the constructor so you don't have to go anywhere on the web. So what is constructor? Constructor, when the method will run whenever the component is created. Here make a note that this method is running whenever the component is created inside the DOM. So as soon as your component is created inside the DOM, the first method that will run is the constructor. Next point here is the constructor flows from parent to child. What I mean from this here is, here you can see the first constructor on the parent will execute. After that, the constructor on the child will execute. And that's why here I am pressing that the constructor flows from parent to child. That means the constructor on the parent method will execute first. And after that, the constructor method on the child component will execute next. Next point here is the first statement in the constructor method will be the super method. It is mandatory that whenever you are putting the callback function constructor, you have to put the super method as the first statement. Otherwise, you will get the compile time errors in your Lightning Web Component. Otherwise, you will get the compile time errors in your Lightning Web Component. So the first line of code in your constructor method will always be the super statement, and here you don't have to pass any parameter. Okay, now there are few points that you should know whenever you are working on the constructor. First one is, don't inspect the elements, attributes, and children in the constructor method. What I mean from this, don't inspect the elements, attributes, and the children. That means you should not find the components there. By using this dot template dot query selector, you should not inspect any component in the constructor, because whenever the component is created, these components and the attributes will not be available. Even the child component is not available, right? Because we are at this stage, and the child component will invoke after the rendered method will be executed. So your child component will also not be available. So you cannot inspect the elements, attributes, and the children inside the constructor. Next one here is, don't inspect elements public properties. Next point here is, don't inspect any public properties. That means you should not access any public properties here. You should not inspect or access any public properties here. In case your logic demands that you have to access the public property, go for the getters and setters that we already discussed in the previous session. But don't inspect any public property inside the constructor method. Next one here is, don't add attribute to the host element during the construction. Don't add any attribute to the host element. For example, most of the times we add the different attributes to the host element. Like if you recall in the previous section, we have done the dynamic styling where we are adding the class, removing the class, where we are setting the label or the title. We should not do any kind of an operation in the constructor method. So don't add any attributes to the host element during the construction. Now there are few questions that most of the times I received over the blogs or over my channel as well. So can we set the properties in the constructors? Definitely you can set the properties in the constructor, but as I highlighted here, you should not do it. Whenever you have to set the properties, you should use the getters and setters. Definitely you will not get any error, but the Salesforce does not recommend that you should go and set any properties in the constructor. Can we access the elements components owned inside the constructor method in Lightning Web Component? The answer to this is no. You cannot access any element. That's what I said here. You don't inspect the elements, attributes, and children. For example, I have to access the Lightning input component in my JavaScript file. I have to access a particular data item in my JavaScript file. I cannot or I should not do that in the constructor method, because in constructor method, if I do, definitely I will get the runtime errors. Next one here is, can we call an apex method inside the constructor? Definitely you can call it, but again, Salesforce does not recommend that you should do in the constructor. You should do it in another lifecycle method, that is the connected callback. And the next one here is, can we create and dispatch the events in the constructor? As we move down the line, we will understand the communication between the components, and that's where the dispatching the event or the creating the events will come up. But again, just take this point as a note here. You should not create and dispatch any custom events from the constructor. So ideally, we should not do anything in the constructor. It's a life cycle method that most of the times we should keep untouched, unless and until you have to set the specific flag or you have to do some workaround. Then and then only you should go for the constructor. But in ideal scenario, you should not go and disturb the constructor lifecycle method. Let me check the chat box if we do have any question. There's a question from the Seda Reddy. What is inspect the element? Any example? For example, Seda, you have declared one lightning input in your lightning web component. Now you want to access that lightning input in your constructor file. Okay, that is what inspecting the element that we have done in the previous session with the this dot template dot query selector or the this dot template dot query selector all. Right, the point that I want to make here is, you should not access any element inside the constructor. I hope I answered your question. In case not, let me know in the chat box. Next one is the connected callback. Now, when the connected callback will execute, connected callback is execute whenever the component is inserted into the DOM. So you can understand this method constructor is getting called when the component is created. So first thing here is creation of the component. That time the constructor will be called. Now, as soon as the component is inserted into the DOM, the framework will call another method, that is the connected callback method. As soon as the component is inserted into the DOM, the framework will call another method, that is the connected callback method. Next point here is, connected callback method again flows from parent to child. You can see this. First, the connected callback on the parent will execute. After that, the connected callback on the child will execute. So the flow for this is again parent to child. Definitely, you can access the attributes, you can inspect the elements in the connected callback. But one key thing here is, you can't access the child element from the callbacks. Only thing here is, you cannot access the child element in the connected callback. Why not? Because as of now, the child element is not inserted into the DOM. Definitely all your host elements, they are inserted into the DOM, but the child elements are not inserted into the DOM. That is the reason you cannot access the child element from the callback. Few points to remember with respect to the connected callback. The connected callback hook will fire more than once. This is very important. Whenever you are doing any coding, you have to always keep in mind that your connected callback hook can be fire more than once. For example, let's say you are making an apex call from your lightning web component, right? So you have to always make sure that you should not hit the governor limits, and for that you have to always remember that your connected callback hook can fire more than once. So whenever you are writing the code inside the connected callback, you have to make sure that the code that you want to invoke only once, it should be invoked only once only. For that, definitely you can use the take a use of helper flag and prevent it. But you have to make sure that your connected callback is not invoking the apex call again and again unnecessarily. Definitely that is the requirement. You can invoke it, but whenever you are building the lightning component, keep this point in mind that your connected callback hook can fire more than once. In what scenario it will fire more than once? For example, let's say you are displaying the components conditionally. So let's say on the click of the checkbox, you are displaying the component. On the uncheck of the checkbox, you are hiding the component. So what is happening here? Your component is getting inserted, removed multiple times, right? So that is the reason connected callback will be fired more than once. What you should do in the connected callback, you should use the connected callback to perform the initialization task. Those who worked on the Aura programming, like we do have the functionality of init event in the Aura. Similarly, in the Lightning Web Component, we do have the connected callback. So whatever the functionality that we generally use to perform in the init event in the Aura, the similar kind of a logic we write in the connected callback, such as fetching the data when the component is loading, setting up the cache, or listening up the events as well. Or you can also listen up the message channel. We will see down the line the few examples when we go and explore the advanced programming, how to deal the communication between the components. That time I will show you how you can use the connected callback to subscribe the events as well. Next point here is few more questions that we generally get with respect to the connected callback. Can we set the properties in connected callback? Again, definitely you can, but the recommendation from the Salesforce here is, if possible, do the setting and the getting of the properties with the setters as well as the getters. Next point here is, can we access the components own inside the connected callback? Here the answer is yes. Here the answer is yes. If I compare this with the constructor, here can we access the elements the component owns inside the constructor? The answer was no. But here in the connected callback, the answer is yes, you can access the host element. But only thing that you cannot access here is the child element. Next thing here is, can we call an apex method in the connected callback? As we discussed, whenever we have to fetch the data, we should do it in the connected callback. So again, the answer is yes, we can make an apex call inside the connected callback. And the last one here is, can we create and dispatch the event? Again, the answer is yes, because that's what we have discussed. We should use the connected callback to listen the events as well as to publish and subscribe the events as well. I hope I make sense with both of the lifecycle methods as of now, constructor as well as the connected callback. Folks, you can utilize the charts if you do have any questions. Moving toward the next part. As of now, we understood what will happen whenever the component is inserted inside the DOM. Okay, now let's take one step further. Now try to understand what will happen when the component is removed from the DOM. For example, let's say you are displaying the components conditionally. In case the condition is unsatisfied, then you want to take out that component or you want to hide that component. Hiding means basically removing the components from the DOM. So again, what all different life cycle will work whenever the component is removed from the DOM. So again, we do have the two components here. One is the parent component and the another one is the child component here, right? So what will happen whenever the component is removed from the DOM? As soon as you go and remove the component from the DOM, the disconnected callback method on the parent will be called first. Which method is coming up here? Disconnected callback. Previously we discussed about the connected callback that is getting called when the component is inserted into the DOM. Next we are discussing about the disconnected callback, which is getting called when the component is removed from the DOM. As soon as component is removed from the DOM, disconnected callback method will be called. Next one here is, after that the disconnected method on the child component will be called. So first disconnected callback on the parent will be called, and after that the disconnected callback on the child will be called next. So again the flow is from parent to child. So what kind of things that we should do in the disconnected callback? Majorly we do the cleanup work in the disconnected callback. Majorly what kind of work we do in the disconnected callback? We do the cleanup work in the disconnected callback. For example, like here we have set up the cache or we have listened the events, right? Here what we are doing? Here we are cleaning up the cache or purging the cache or removing the event listener as well. So whatever the work that we have done in the connected callback, we use the disconnected callback to undo that work. We use the disconnected callback to undo that work. Okay, so that is my another life cycle method, that is the disconnected callback, which is getting called when the component is removed from the DOM. Moving towards the next life cycle method, that is the render method. Now what is render method? Render method, it is useful whenever you have to switch your HTML templates. Whenever you have to switch your HTML templates. For example, try to understand this example very carefully when you should go for the render, when you should go for the render one, or when you should go and use the multiple templates. Whenever you have a kind of a functionality where the JavaScript logic is common. Listen me very carefully. Whenever you do have a kind of a functionality where the JavaScript logic is common, but the way you have to display the data is totally different. But way you have to display the data is totally different. In such scenarios, only you should go for the render event. Again, Salesforce do recommend that rather than you go and use the rendered event, first you should always evaluate if that requirement can be achieved with the help of LWC if, else if, and the else directive. Because we also discussed with the help of these directives, we can conditionally display the elements on the HTML. So rather than you go and use the rendered event or override the rendered event, always evaluate the possibility if the same thing can be done with the help of LWC if, else if, or the else directive. The reason for this is the performance. If you are going with this one, then definitely you will get the better performance as compared to the render. Definitely you will get the better performance as compared to the render. So the key thing about the render, as I said, render always return the reference of the HTML template. Always returns the reference of the HTML template. Your render method will always return which HTML component should load on the UI. Let's take this as an example. Here we do have, this is the component. Now in this component, you can see I am importing two different HTML template. First one is the template1.html. Second one is the template2.html. What I am doing here is I am importing two templates. Assume that both the templates will have the different way of displaying the data, but the business logic that they required is common, which is available in the JavaScript. Now here what I am doing, here I am overriding the render method. Overriding means just declaring the method and writing the logic. That is nothing but overriding the render method. Now in this method, what I am returning, here I am checking that what is the flag value. In case this value is true, then I am returning the template1. What is template1? Template1 is the reference of template1.html. Template1 is the reference of template1.html. That's what we discussed here. Render method always returns the reference of the HTML template. So here we are returning the reference of the HTML template. In case this value is false, we are returning the reference of the template2. So initially my component, when my component is loading, what is the value? The value is true. So when my component is loading, which HTML will render? Template1. Right? Let's say I do have the button to switch the template. Then I go and switch the template and render the template2. But again, I am repeating, before you go and use the rendered method, always evaluate the possibility that if you can achieve this requirement with the help of these directives. Because the render method, it comes with the performance hit. Next one is the rendered callback method. Now what is rendered callback method? Rendered callback method, it fires whenever the component rendered. Whenever the component is rendering. Now what I mean from the render, in what scenarios your component will be rendered? Your component will be rendered. This is very important. As I said, with rendered callback method, it will be called whenever the component renders. But what I mean from the component is rendered. So that means when the component is rendered, when the value of the property changes. For example, at the class level, you have defined one property. As soon as the value of that property is changes, your rendered callback will automatically execute. Whenever the value of the property is changes, then your rendered callback will automatically execute. For example, like here, we do have the property as the show template one. If this property value is changing, like we are changing the value of this property here, what will happen? Automatically the rendered callback will execute. First scenario, as soon as the value of the property changes and that property is used either directly in the component template or indirectly in the getter of a property. The property that we have defined, if that is used on the HTML template or it is used on the getter method, your rendered method will be automatically invoked. Again, I am repeating, when the rendered method will be invoked, whenever the value of the property changes and that property is used on the HTML file or that property is used in any of the getter method, then the rendered callback will automatically invoke. Now, how the rendered callback flows, and this is the twist here. Rendered callback flows from child to parent. As of now, whatever the methods that we have discussed, every time the flow was parent to child. Rendered callback is the only one where the flow is child to parent. Why child to parent? Again, if you see here, now as soon as the rendered method is executed, the control is transferred here. First, the rendered method on the child will execute, and after that, the rendered callback on the parent will execute. So the flow here is child to parent. Now, as you might have already understood that your rendered method will be invoked multiple times, because as soon as the property is changed, rendered method will execute. So whenever you are putting any logic inside the rendered callback, you have to always evaluate the possibility that is my performance is going to be the impact. Or in case you want your logic should execute only once, then definitely you have to do the spatial handling of the code, right? Because whatever the logic that you are writing in the rendered callback, it will be executing multiple times automatically, because your callback method is getting called multiple times here. So you have to be very, very careful whenever you are writing any logic inside the rendered callback. Right? Because most of the times whenever you go and use the rendered callback and you are not taking any special care, you will cause an infinite loop kind of a scenario. And that is the reason updating the state of your component in rendered callback is not recommended. Next thing here is you should not update any wire adapter configuration. Most probably in today's session, we will discuss more about the wire adapter configuration. But for the time being, you can assume that wire adapter configuration object is the reactive property of the wire adapter, which will, when that reactive property is changed, your Apex method will be called. So you should not update a wire adapter configuration object property in the rendered callback. And also you should not update any public property or any field in the rendered callback as well. There are very specific use cases when you should go for the rendered callback, and that is whenever you are working on the third party components. For example, you have to load the third party JavaScript in your Lightning Web Component. You have to load the third party CSS. You have to load the static resource in your component. In such scenarios, only you should go for the rendered callback. Otherwise, you should definitely avoid the rendered callback method. Last one is the error callback. This is the last lifecycle hook method. Now, what is error callback? Error callback, this method is used to capture the errors that may happen in all the child components lifecycle hook. When like it is more like a try-catch block that we do have in our Apex programming. With the help of this error callback, we can catch all the errors coming from the child component. In this, with the help of this method, we can catch all the errors that are coming from the child component. So this error callback method, it takes two parameter. First is the error and second is the stack, where error is the object and stack is the string, where error is the error object and the stack is the string. So error callback always comes with two parameter. Next point here is error in the parent, it will shows in the UI. In case the parent component throws any error, then definitely there is no way to handle it, because the error callback, it will handle the errors that are coming up from the child component. If your child component is throwing an error, then your parent component can handle that error with the help of error callback. But if your parent component is throwing the error, then that error cannot be handled. It will be automatically displayed on the UI. As I already highlighted, it works more like a catch block on the JavaScript. Right now, what we will do, we will try to understand these lifecycle methods with one very simple example, where we will understand how the flow actually works in the lifecycle method. So again, let me navigate you to the editor, and here I go and create the two different component. I am naming the first component here as the parent hook. This is my first component, and I am creating another component here, and I am naming that component as the child hook. Right now, in the both the methods, I will go and define the lifecycle hooks method. So here I go and first put the constructor. As I said, whenever we are using the constructor, what is the first line that we have to put? Kindly let me know in the chat section. Meanwhile, I am forwarding it to the next method. Once I got a response in the chat section, then I am go and write that method name in the constructor. Meanwhile, I am moving it to the another method, that is the connected callback method. Next method that we also discussed here is the rendered callback method. We will take a separate example for the render, but for the time being, let's just focus on the more lifecycle methods. That is the constructor, connected callback, rendered callback, and last one is the error callback. As I said, error callback method, it takes two parameter. First is the error and second is the stack. This method, it will take two parameter. First is the error and second is the stack. Similarly, I am defining this four methods at the child component as well. Okay, now here I am writing the statement first one as console.log constructor from parent. I just want to explain the flow here. That's why I'm putting all these different console.logs. Here I go and put connected callback from parent. After that, here I go and put rendered callback from parent, and in the end I go and put error callback from parent. Right, similarly I go and define the different methods for the child component as well. I'm just putting one console statement so that we can understand the flow. Here I am putting constructor from child, here I go and put from child. Now here I go and put rendered callback from child, and in the last I am putting here is the error callback from child. Okay, very simple. We have put the two different life cycle method, but again in the constructor we are again missing one statement. I didn't get any response in the chat section, so let me go and revise one more time. So whenever we are dealing with the constructor, the first statement must be the super without any parameter. So what we have to do here is, in the constructor, before we go and execute any logic, we have to write down this super statement here. So here I just go and put the super statement. So what I am doing here is I'm navigating back to my HTML. Here I go and put a lightning card. putting a title here as Lifecycle Hook Demo. And what I am doing here is from the parent, I am invoking the child component. So how to do that? See, child hook. We already discussed whenever we have to compose the component, we always do the composition in the kebab case. So here I am converted this child hook into the kebab case. And let me go and deploy the child component here. And also I am exposing the parent component here. So here I go and define this as the true and defining the targets here. Let me go and deploy this. So here I go and add this component on the UI. Sorry, I have to edit this page. Meanwhile, folks, if you guys do have any question, you can let me know in the chat section. So here I go and remove this. And we have created the component here as the parent hook component. I'm just dragging and dropping that component here. Let me save this and go back. Okay, let's go and try to understand the console.log so that we can understand the sequence that we are getting. So here I go. Now, if you check here, what is happening? First, sorry, first the constructor on the parent is executing. After that, the connected callback from the parent. Is I am executing all these methods? The answer is no. Who is executing all this method? Framework is executing it. After that, immediately the control is transferred to the child component here. After that, the constructor on the child component is executed. After that, the connected callback from the child is executed. Next thing here is rendered callback from the child is executing first. The key thing here that we already discussed with respect to the rendered callback, your rendered callback will always flow from child to parent. So what is happening here is rendered callback on the child is executing first, and after that the rendered callback on the parent is executing. Right, that's the thing that I want to show you here, the sequence. One key thing we also discussed about the rendered callback method here is rendered callback method or the connected callback method will be getting called multiple times. Also, we missed to define one more lifecycle hook method in both the components, that is the disconnected callback. So let me go and define here the disconnected callback as well. And so let me go and put here the disconnected callback from parent and disconnected callback from child. Okay, now to show you an example of the rendered callback, it is getting called multiple times. What I am doing here is I am defining one lightning input field here. So let me go and define one lightning input of type checkbox. And here I am putting the label as invoke child. Okay, and when this checkbox is checked, then and then only we go and display this child component, otherwise we will hide the child component. So to track that change here, I am defining here the change handler as well. So here I go and on change, I am defining the change handler. Right, so as soon as this any action has been done on this component, what will happen? This change handler will execute. So let me go and define the change handler as well. So here I go and put the event Now let me go and define one property to track that, and let me put here is the display child, and I'm initializing this property with the false. So whenever the user go and check this checkbox, what will happen here is we go and populate that value. So this dot display child is equal to event dot target dot how to handle the value from the checkbox by using the checked attribute. If you are not sure about this checked attribute, definitely you can revisit the previous sessions of the conditional rendering, and also you can revisit the documentation of checkbox as well. I explained already how the checked attribute will work. So what I am saying here is this display child component, it should be invoked only when this checkbox is true. So here I go and check if the checkbox is true by using the LWC if. So if this checkbox is true, then and then only my child component will be invoked. In my child component, I am putting one message here. Welcome to learn LWC on tech journey with Ankit. Okay, and I am adding some padding here. So let me put here the padding SLDS P around small. Okay, I have not done anything as of now. What I am doing here is I have put one field. On the click of the field, I am setting up this value. The point that I want to show you here is how your rendered method will be automatically called multiple times here. Let me go and deploy this. Meanwhile, folks, if you do have any question, utilize the chat section to have your queries here. So I have deployed my child component. Let me also deploy my parent component as well. So both are deployed. Let me go to the org, refresh the page. I believe, if I am not wrong, I missed to add some padding here. So let me add some padding, otherwise it will be very close to the border. SLDS, let me refresh it. Right. So on the click of this checkbox only, what we have to do, we have to go and invoke the component. So let me again show, navigate to the inspect, navigating back to the console. Now here one key thing that you note here is as compared to the previous one, now this time only we do have the constructor from parent, connected callback from parent, and the rendered callback from parent. Here we don't have any child components. Why? The answer is because of this boolean flag value. As of now, my child component is not created or inserted inside the DOM. So when my child component will be inserted into the DOM, as soon as I go and check the checkbox, so here I go and check the checkbox. So let me go down and I'm checking the checkbox. Sorry, we are getting any one error here. What is the error? Let me go to the code quickly. Hmm. Script error. Event dot target dot checked. I believe I'm doing correct, but let me quickly check one more time. LWC component library. Meanwhile, I also put the debugger here. Parent hook. Scrolling down. Here is the logic of on change. We are not defined. Okay, sorry. I have defined by mistake this change handler on the child component. It should be on the parent component, because on the parent component only we are tracking the values. So it should be on the parent component only. And this flag should also be on the parent component. It was a typo from my side. I have mistaken this with the different component. So on the parent component, I do have my change handler, and I do have this flag as well. And my child component is quite untouched. So let me go and deploy this one more time. Yes, Sunil, I understood. Thank you for confirming on that. Okay, so if I go and check this checkbox, now this is working as expected. So let me go and refresh it and explain you from the start. So here I go, click on inspect, navigate to the console. You can see here we do have the callback methods from the parent is invoked. Now here if I go and check this checkbox, what is happening here is if I scroll down, you can see the constructor from the child is called, connected callback from the child is called, rendered callback from the child is called, and again the rendered callback from the parent is getting called. So how many times as of now the rendered callback from the parent is getting called? The answer is twice. Here it is getting called once, and after that again if I check this checkbox, it is getting called twice. Right? Now let me clear the console, and what I am doing here is I am just unchecking the flag. As soon as I uncheck the flag, my child component is removed from the DOM. As my child component is removed from the DOM, disconnected callback from the child is getting called. What is happening? As my child component is removed from the DOM, disconnected callback from the child is getting called. But again, my rendered callback from the parent is getting called. The answer is why? Because here again I am changing this property. So every time the property is changed and that property is available on the HTML, or that property is used in the getter file, every time your change handler, every time your rendered callback method will be called. So again, if I go and add this component, again the rendered callback from the parent is getting called. If I go and hide this component, again the rendered callback from the parent is getting called. Right? Even if I go and check this again, even the rendered callback from the parent is getting called. Right? Another thing that we discussed here is about the connected callback. The connected callback, again, it will be called multiple times as well whenever the component is added into the DOM. So you can see here, as soon as the component is added into the DOM, my connected callback method is getting called. And definitely by rendered method, callback method is getting called multiple times. Right? So this is the few points that you should know whenever you are working on the lifecycle hook. Now the next thing here is, let me go and throw one error, because you have to also understand the significance of the error callback as well. So what I am doing here is, here I go and just throw some error when my component is loading. So here I go and throw the error. So to throw the error, I am putting here throw new error and putting the error message here as error while component loading. What I am doing here is I am throwing the error from the child component. As soon as the error is coming up from the child component, my error callback is getting called automatically, and we get those error details here. Definitely after that, it's up to us what kind of customized message that we have to send to the UI. So here again, I'm logging both the different things. I'm logging the error as well as the stack information. The stack information will give you the details from where the error is coming up. So the error is the one, and here I go and put the stack as well. As I said, whenever we are dealing with the error callback, we do have the two different parameters. First one is the error object, and second one is the stack argument, which is nothing but a string. So let me go and deploy the child component, and also I am deploying the parent component here. Here I go, and let me refresh it one more time. Okay, now let me go and again open the inspect, navigating to the console. So we do have all these methods which are getting called. I'm just clearing the console for now and invoking my child component here. You can see here, as soon as I invoke the child component, from the child component, what we are doing, we are throwing the error message. As we are throwing the error message, my error callback from the parent is getting called automatically. My error callback from the parent is getting called automatically. Now under this error object, you will have the complete details about the error as well. You have to look for it, or you can go and stringify it to get the complete error message. There is a property, if I am not wrong, that is the error dot message, which property will give you all the details about the error callback. But the key thing that I want to show you here is you can get all these error details by displaying the error details. Let me quickly log catch up this error object and get the property details about the error object. So here I am putting the JSON dot stringify, and here I'm passing the error object. Okay, as of now I'm not getting any error details. Let me put here, it is in error dot message. Yes, it is in the error dot message, error while loading the error while component loading. This is the error message that we have thrown from the child component, right? Error while component loading. To display that message, we have to use the error dot message property. So under this error object, we do have all the details. Similarly, the stack details will give you from where the error is coming up. So you can see we are getting the complete stack. The error is coming up from the child component, and we are displaying that in the parent component here. I hope I am making sense to you folks about the lifecycle hooks. I hope you guys got some learning on this lifecycle hooks. Now there is one last slide that I want to present here about how you should organize your code in the client side controller. What are the different best practices that Salesforce do recommend to organize the code inside the client side controller? Because we have seen there are too many things, like we do have the decorators, we do have the life cycle methods, we do have the getters and setters. We also go and write our own customized methods as well. So what kind of sequence that we should follow as per the Salesforce? So what the Salesforce recommend here is we should go and definitely go and perform all the inputs first. What all the different inputs that you have to do. After that, you should go and define all the @API properties. That means all the public properties, followed by the private properties, and followed by the wire decorators. So all the decorators should come in the top. First the public property, second the private property, and in the end we should have the wire decorator. After that, we should go and define the lifecycle methods. Whatever the lifecycle methods required as per your logic, you should go and define all those lifecycle methods one after the other. Definitely, if you are using the constructor, you have to use the super statement. And after that, you can write down the constructor body. Right? In case you have to access any properties, you have to make any apex call when the component is loading, definitely you can go for the connected callback. After that, you should go and define as many getters and setters you do have in your component. Definitely when you go and try to start building the complex components, definitely there will be more than one getter as well as setters. You have to make sure that you are putting getter and whatever the setter related to that getter one after each other. Most of the times I see that people do define all the getters at one place and all the setters in the end. Don't follow that. For the better code readability, put all the getters and setters together, right? And after you have done that, whatever the functions that you have to do, you can go and define all those functions here. For example, you have to define the on click handler, you have to define the change handler, you have to define the submit handler. Whatever the handlers that you have to define, put that handlers in the end. Okay, so this should be the sequence that you should follow whenever you are designing the client side controller. Definitely we will talk more about the best practices as we move forward, but I just want to give you the glimpse about how you should organize your code in the client side controller so that you will follow all the best practices recommended by the Salesforce. Any question, folks, before we drop the session today? Thank you everyone for joining the session. Have a good time. If you guys like the session, make sure to hit the like button and also subscribe the channel as well. Thank you.